Okay, good. Let me see. Okay, now we will start our lesson today. So before we start, do you have any question? Now, okay. Now today we are going to discuss a topic. It is about the structured cable system. Now, actually, so far we introduced to you some system found in the building, right? For example, we have the lift system, sorry, not life. We have the security system, in terms CCTV, security system, and we have the network system, etc., right? Now, actually, in a building, we try to integrate all of the system into a single system so that we can manage them easily. Therefore, we needed to have an integration, okay, to a central monitoring system. And therefore, in the last two topics, we are going to describe how can we make the integration. And firstly, we are going to talk about the cable system, so that we are going to discuss how or what is the feature we found in the cable that make the connection between individual system to the monitor system. Okay. And therefore, here you can see that our objective is to introduce the cable system to you. And firstly, we are going to talk about the problems we found in the existing cable systems. And then we are going to talk about the standards. And we give you some categories that we mostly found in our building. And also, we are going to tell you the major problem found if we are going to transmit some high frequency signal through the cables. And finally, we give you some idea on the subsystems in the cable systems. Okay. Now, firstly, now you may find that when we describe each individual system, now they should have some specific type of cable and the connector, okay? Because they are made up by different or individual manufacturer. They should supply their own cable or connector, such as if you are using iPhone, it is using the Lightning connector. If you are using the Android phone, it is using the USB Type B or Type C socket to make the connection. Now, therefore, you may see that different company may using different connector, and it make our work to make the connection to a central monitoring system become really difficult, because actually we don't have any standards on the connection. Okay, no standards. And here on the right hand side, you can see we give you some example that you can see for the UTP, that means the unshielded transistor paired cables that we will going to describe to you. It is using the UTP 3 pairs, okay? And for the microphone, it has specific connector, and using the micron fiber, okay? And now we have the twin net connector. Twin net, it is a kind of coaxial cable okay, that it has two inner connector inside. Now, for the coaxial cable, we will describe to you, okay, and for the coaxial, it is mainly using the BNC connectors, the Bowlet network connector, or what we call the Bowlet nail consumer connector, BNC. Okay, and you have STP, shielded STP, shielded twistor pair cables, which may use in the computer. Okay, and it specify the impedance for the cables. Okay, and we have the RS232 cable, which is using in the serial connection between the computer and the other device. We have the 50 coaxial cable, and also the dual 75 coaxial cable. Now you can see that the cable may specify the resistance because it help the designer to doing a impedance matching in order to maximize the power transfer to the system. Okay. Now, so from this table, you can see we have many different types of system. Therefore, it makes our connection between them it become really, really difficult. Okay. So we tell you that the cabling difficulty is that different cable systems are used in different systems. So if you are going to migrating from one type of computer system or network, it becomes very difficult. In most cases, the entire cable systems should be replaced. Okay, because when you replace another computer, that it may use another type of network or cables or connector. Therefore, at the same time you replace your computer, you should also replace the cable. Therefore, sometimes when we calculate the cost to replacing the system, together with the cost of the network, we found that they are very expensive. Okay, because we are also requiring to replace the cable in our systems. Okay. On the other hand, we have another challenge because most likely you may find the cable may have some or certain extensions. When you hire a new employee or you add a computer inside your network, now sometimes it again makes the cost become expensive because you have no way to extend your network. For example, if you are using the bus topology, okay, bus topology means that if you have some computer or system and they are connecting to a bus, okay, which can transmit the data. Now, when you are going to connect a new system to the network, now what you are going to do in the older days is that you are going to break down a cable in order to insert a new system. Okay. Now, as a result, when you make the installation of the new system, it makes your whole network become shut down because you needed to break it up in order to install a new system. Now, therefore, you may see that if you by extension or by extending the systems, it may cause a company a lot because during the installation, the whole business may be suspended. Okay. Now, therefore, we should find a solution to solve this problem, especially in a building. You cannot afford any suspension of any business, right? Because time is money. If you make suspension, that means you lose money, and no one wants to lose money, right? Therefore, we introduce to you the structured cable so that it can make the installation of new system become feasible, and also it helps us to, when we replace the systems, we do not require to replace the whole cables, and this is our goal. Okay. Now here we give you a summary about the cabling difficulty. What we call tells you that all of the system have low structure. They are non-structured. Okay. Therefore, it is impossible to migrate the computer system from one to another without replacing the entire cabling system. On the other hand, if you are going to make the move, change, or addition, the cabling system is also needed to change. At least we needed to suspend, okay? Because the cable system has no real structure. That means it is loosely configured. When you are going to add a new system, you needed to break it up in order to install the new system. Therefore, if you are constantly changing your user requirement, then you better using a structured cable. Otherwise, you may suffer from the non-structured cable by replacing the cable or break down the cable in order to install the new system. Okay. Therefore, we told you we have the solution. It is the structured cabling system, CSC. Now, the primary goal of the CSC is that I needed to correct it. It should be SCS, right? We're using the first letter of the structural cabling system, okay? SCS. Now, the primary goal of SCS should be that once the cable has been installed, it should be rarely needed to be changed because replacing cable it is very expensive. And normally, we are using a star topology that we introduced to you in our networking system, so that in the middle, we have a hub, okay? And this hub will perform a signal repeating to all of the connection to each device, okay? So that when you are going to replace one of the system in the network, you are no need to shut down the network, okay? And also, you can easily extend your network by connecting your hub to another system, okay? Now, therefore, we found that the star topology is very, very convenient using in the structured cable system, okay? Also, later we will describe to you in the SCS, some other component may be exit. We have the horizontal wiring, and you may connect them with the appropriate hardware. Now, the horizontal wiring means that we connect the system and the hub in the same floor. Okay. Same floor. Therefore, the cable are installed horizontally, and we give the name horizontal wiring. Okay. And later we will describe the horizontal wiring to you. Now, actually, during the construction of the building, you are going to prepare that where we install the cables. And once the construction of the building is completed, the next stage, so that the building services engineer go into the building to install the cables. At that time, we are talking about the pre-wiring of the cables. Okay, no matter it is in a new building or in the existing building, and we are using the star topology. Okay, and all the future move, changes, and addition can be made quickly and easily by simply removing patch. That means a short pieces of cable in a centralized wiring cordslet. Now that means that in a floor, if you have a system here, and you will connecting a cable to a socket, okay? And this socket will be further connecting to a centralized wiring closelet. And this is our configuration. And what you are going to do is that you are going to make a cable connection between the socket and your system, okay? And then you can connect your system to the network, okay? Now, therefore, by simply changing the attachment of the cables and the device at the equipment rack, so that the sockets and the equipment has a socket and also the workstation outlet. Using the structural cable system, it can be adapted to various system and interface very easily. And also, nowadays we are mainly using a little type of connection. We have the wire connection. Okay, we follow the standard that we are going to introduce to you. Or you remember that most likely nowadays we make things use the USB connection. Okay, therefore it makes our life become easier. You can imagine that if you have so many different cable you are going to connect, then you make different sockets on the wall, and it, again, make it difficult to make the connection. But nowadays we are mainly using USB connection, then it makes the engineer life become easier, right? Okay. Now here we talk something about the standard we can follow. So far we have 3 standards: the international standard, ISO 11801, and European standard EN 50173, and America standard, okay, ANSI 568A-A. Okay, now we have many standards that we can follow, and actually when you have a building containing about 50 people to a campus about 50,000 people, you can follow the standard. And in Hong Kong, we mainly follow the American standard. Okay, therefore, when you go out for work, you may get familiar with yourself about this standard. Okay, now please notice that it is not a legal requirement, but it is a voluntary basis, so that if you are going to make your work become easier, you may follow the standard, because many vendors or supplier they using the same equipment or the connection methods suggested by the standard. Okay, therefore you may follow the standard. Okay. Now under the 568 standard, okay, it contains some substandards so that you can refer when you are going to doing that kind of work. For example, for 568 AB, it is for commercial building telecommunication wiring. Okay. For 569A, it is for wiring pathway and space. Okay. For 5670 standard, it is for light commercial or residential telecommunication cabling. For 606, it is for telecommunication cabling system administration. And 607, it is the telecommunication system grounding and bonding. That means how can you make the connection between the wires and the device. Okay. Therefore, when you work with that kind of project, you may refer to the standard, and you can strictly follow the standard, and you can make the system become connected. Okay. Now here we introduce to you a bulletins because we told you that it is not a legal requirement for the standard. And how can we get the information? And most likely the engineer will get the information from these technical services bulletins. Okay, it is published on the web, and it specifies the cables to be used. For example, TSB46. It is about the UTP. UTP means the unshielded twistor pair categories. And we have normally it's starting from category 1, category 2, up to category 7, or I can remember we have 7A now. Okay, and they have different bandwidth, different length, and different requirements. Okay, and we have TSB40A. It is the connecting hardware for the Cat 3 to 7. And if you are working with the shielded twistor pair hardware, you may refer to 53 specification. And if you are working on the SOM distribution system, that means in a very large area, you can identify some SOM inside the area. Okay, A, B, C, D, for example. If you are going to working on SOM distribution system, then you may refer to TSB67. Okay. So under the 568A for the cabling, we build up some subsystem in a building. Okay, and we will describe to you one by one at the end of the lecture. It including the building entrance, equipment rooms together with the main course connect. Course connect means we have the network to network interface, so that we connect two different type of network to make it to connected. Okay, we call it the course connected. We have the main course connect or intermediate course connect. Okay, we have the backbone cabling, telecommunication courselet. Okay, courselet means we have a let me see. We have a box or a cabinet that store the equipment inside. Okay, and we have the horizontal cabling and work area. And you can see on next page, we have a diagram to describe each of the subsystem for the structural cabling. Now we have the main building entrance, where we have the main course connect. We have the equipment room. You can see that we have the intermediate course connect here. And to connect the telecom courselets for each floor, we have a backbone. And out of the telecom courselets, we have the horizontal cabling. And in the floor, we have the work area. Okay. So now from the picture, you can see the location of these subsystems. And normally, the user only work in the work area. Okay. And the engineer can make the proper correlation between different subsystems to the buildings in order to make all the system become connected. Okay. Now here we have two tables to show you the cable categories. As I told you, up to now we have Cat 1 up to Cat 7. And you can see that Cat 1 it is used in telephone line. Okay, and the data rate is very slow, only 0.1 megabit per second. And Cat 2 you have T9 or T1. Okay, another name is T1. And actually it is a bundle of 24 digital telephone line together. Therefore, the data rate is larger, up to 2 megabit per second. And starting for Cat3, we use them in our network. Okay, nowadays I think no one will use Cat3 because or Cat4 because the data rate is not high. Okay, at least we are using Cat5, which support a data transfer rate equal to 1 megabit per second. Okay, and you can see that in Cat5 it is a cable wire, normally consists of 24 AWG. AWG stands for the America Wire Gauge. It is published by America Standard. Okay, it specifies the dimension of the cable. American Wire Gauge. Okay, AWG. And if you follow the standard, you can achieve the data rate normally. And it has an extension 5E, which support a higher data rate. Okay, and Cat6 and Cat7 normally we are using now because we get a faster Ethernet. Okay, 1G Ethernet. We should using a better cable in order to make our transmission become better. Okay, and if you have an experience to connecting a cable to your router and your computer, okay, now this is your router, this is your computer. Now you can observe the specification of your router if it support 1 gigabyte or 1 gigabit per second. If you only connect a Cat5 cables, okay, that means you do not achieve the maximum speed provided by the router. Okay. Now, therefore, the cable selection is also important when you build up a network. Okay. Now, to the right-hand side, you can see again we showed you the cable category. Now you can see nowadays if you are using a 1 gigabit Ethernet, you may see that a Cat7A cables, okay, in order to achieve a maximum data rate. Okay. Now actually, remember we told you the OSI model in the network. It has 7 layers, and for the cable system, it refers to the physical layer. That means the layer 1 in the OSI model. And cables, it is nothing more than transmit signal from one location to another location. And you can see from the bottom table diagram that in the sender in a physical layer, it sends a signal through the cable or media to another receiver, okay, under the physical layer. And the signal usually represent in the form of electromagnetic energy. Okay, it can be EM wave or voltage. Okay, and during transmission, the sender and receiver guide the propagation of the signal through the transmission media. And normally, we will find some attenuation because we get some loss during the transmission, or we have noise corruption such that the signal received at the receiver may not be exactly the same to the original data. Okay, and this is why we told you that nowadays we rely on the digital transmission. Okay, because the tolerance to noise for digital signals should be better than analog signal. Okay. Therefore, nowadays, if you have a fast speed transmission, we may using the digital transmission. Here we give you a class of transmission media. We divided into 2 classes: the guided media or unguided media. Okay, unguided media, it means we transmit our signal through the free space using the RF radio frequency signal. Okay, and today we don't talk about this path. We focus on the guided medium, and it includes a twist pair cable, the coaxial cable, and also the fiber optic cable. And they are popular use in our network connection. Okay. Now for the guided medium, media normally it provide a conduct so that we have a pi that make the cable pass through in order to make the connection. And signal travel along this medium is directed or guided. And they are constrained by the physical limits so that we may depend on the attenuation factor or the delay factor for the physical medium. Okay, and we want to transmit our data as fast as possible. Therefore, we try to evaluate our transmission cables and also the transmission methods. And nowadays, as I told you before, the network cable usually support a maximum data rate up to 10 gigabit per second. It is a very fast speed. Okay. And the cable we are going to describe to you, including the twist pair cables. And under this category, we have the UTP, unshielded twisted pair cables, or shielded twisted pair cable STP. We have the coaxial cable, but nowadays, coaxial cable may be phased out because the transmission speed is not that high. And normally, we are looking for optical fiber because it supports a fast speed on transmission. Okay. Now for the twist pair cables, it has two conductors, normally copper, and they have the own plastic installation, and we have twisted together. Okay, and on next page you can see that the meaning of twist pair. It means that you may see that the arrangement of the cable is that for cable 1, you may see that at some time it will appear at the top. Okay. At some incidents, it may appear at the bottom. Okay. Now the arrangement of this is that it is going to cancel out the electrical noise from adjacent pairs. Okay, so that the crosstalk, okay, or noise that inject in your cable. Now the crosstalk actually it is a phenomenon that a signal transmit on one circuit that may be affect the other circuit, okay, in the same in the next channel due to the induction effect, okay, or the capacitive effect. Okay, remember for the RL circuit that you learn in the electric circuit engineering, you may see that if you bring two coils close together, the voltage may be induced from one coil to another coil. And also, if you make two conductors with different amount of charges, you will create a capacitor effect between these two cables. And this of the voltage induced or the charge up voltage may affect your signal in the cables. And they are so-called the crosstalk. And therefore, in order to reduce the crosstalk, the simple arrangement is that we make the twisted cable in order to cancel the crosstalk from one cable to another. Okay. Now you can see that for the UTP, normally we have 4 pairs of twisted pair cables. Therefore, you should make it to become twisted, or otherwise the crosstalk will become series. Okay, and you can see that now this is the UTP structure that we will describe further to you later. And you can see that they are using different color to tell the user the 4 pair of circuit inside the cables. Okay. And this picture told you how the crosstalk appear. Now you can see that now if you have 2 twisted cables, the voltage is input at the left-hand side of the top cable, and it is so-called the rear end. And because the voltage may be induced, therefore it appears to us is the rear end crosstalk. Okay. At the right-hand side, because it is the destination of the voltage, therefore we call it the far end. And this again will induce a voltage or make the crosstalk to another cable. At that time, we have the far end crosstalk, FEXT. Okay. Now at the bottom, we do the reverse so that we input a signal at the bottom cable. Therefore, eventually it makes the right-hand side of the top cable become near end crosstalk. And at the left-hand side, because it is the voltage output, it makes the far end crosstalk to the top cable. Okay. Now, actually, this diagram shows to you the dual path communication already. Remember, dual path means that at the same time, the 2 system, okay, connecting by the network can transmit at the same time. Okay, therefore you can see that the crosstalk can appear in both ways. Okay, it depends on you determine which you focus on which system. If you are looking at system A, you may consider that the rear end crosstalk will induce in another cable is at the left hand side. But if you consider that B is sending out a signal, at that time the right hand side it will induce a rear end crosstalk at the right hand side. Okay. Now, no matter the rear end crosstalk or far end crosstalk, you needed to suspend or suppress the crosstalk in the transmission. Okay, or otherwise your signal will become wrong. And here we try to introduce to you the difference between STP, shielded twisted pair, and unshielded twisted pair cables. Now for the STP cable, we have a metal foil or a bladed mesh so that we use a copper to build up a lens, okay, to surround the cable. And they are shielded so that each pair of the conductor is insulated, okay. Now, you can see that on next page, we show you the shielded cable. You can see we build up a base that surround the cable in order to make it to eliminate the interference from the other cables. Okay. Now, you can see that for this structure, now you can improve the quality of the cable by preventing or penetration of noise and crosstalk, but it is bulkier and also more expensive, right? Because you have additional process to make the cable, therefore it become more expensive. Okay, now therefore most likely we may using the UTP, okay, unshielded twisted pair, and they are made up by copper wire, do not have braided mesh, but insulated carefully by choosing material to provide high bandwidth, lower attenuation, and crosstalk. Okay, you can see the structure that in the UTP, we do not have the base. Okay, but we carefully twisted the cable in order to make the crosstalk can be attenuated. Okay. Now for the UTP, nowadays we have 4 pair of cables. Therefore, altogether we have 8 wires. And nowadays we are using the RJ45 jack. Okay, it is the register jet. Okay, you can see it has 8 channels inside. And what you are going to do is that you are going to put the male connector to the female connector, and then that's complete the connection. Okay, because the RJ45 make the connection only in one way only. You cannot reverse the male connector to insert into the female connector. Okay. Now, as I told you, in the older day, we using the coaxial cable, but nowadays we seldomly found the coaxial cable due to the speed is slower. And we can still find the coaxial cable in the equipment. For example, if you are using a CRO to connecting to a pop, then you are using the coaxial cable. And in the coaxial cable, we have a central core conductor which bring out the signal. Okay, and it can be solid or strap wire. That means it is again in order to reduce the material use, you may using a standard wire. Okay, standard wire means parts, some part of the wire made up by copper, and it is enclosed in an insulating sheath. Okay, that means a protection. Sheath means a protection. Okay, and which is further encased in the outer conductor of metal foil or blade. Okay, now on next page you can see the structure. You can see we have the inner conductor. Normally it carry a positive voltage, and you can see that we have the insulator here and here, and in between the two insulator we have the outer connector. Normally it is the ground. Okay, in order to complete the circuit. Okay, and therefore the outer metallic warping serves both as a shield against noise, because it is normally connecting to ground, and it can eliminate the noise injected to the cable, and it is also the second conductor which complete the circuit. Okay, and they are enclosed in an insulating sheath that the whole cable is protected by a plastic cover. You can see that at the outside we have a plastic cover in order to protect the whole cable. Okay. Now, similar to the UTP or STP, we have some category for the coaxial cable, and it can be specified by the radio government number, RG number. Okay, and normally it specifies the impedance, okay, and the usage of the network. Okay, for example, RG59, the impedance is 75 ohm, and you may connect it to a cable, TV cable, or the connect your TV set to the antenna. Okay, now therefore, in the household socket for the antenna, it may specify to you it is equal to 75 ohm. Okay, and you needed to buy the same impedance cable in order to make the signal transmitted correctly. Okay, And it specifies the wire gauge of the inner product. Wire gauge means the thickness, the standard thickness, okay, of the cable. The thickness of the inner insulator and the construction of shield, etc., etc. Okay. Okay. Now, the coaxial cable normally we are using the ball network connector, okay, BNC, and it is using in a bus network in the older day. And we still, if your network is very old, you may using this kind of connector, T-joint, and also the terminator. Okay, but nowadays we don't use them anymore because we are using the star topology. Okay, using a hub. But if you are using a bus network, you may see that your computer will connect to a network using the T-joint. The network is connecting using a T-joint. Okay, this is the network. And you are going to connect your computer, okay, using the BNC connector to this one. Okay, at both ends you have the terminator, or here we have the server, and at the other end you should have the terminator connecting to this one. Okay, but I think you seldomly seen this network anymore because they should replaced by the star topology. Okay. Now the next type of fiber that we plan to use in the future, it is the optical fiber because it supplies us with a very fast speed because the transmission EM wave we using light to make the transmission. Now the optical fiber, it is made up by glass or plastic, which is going to transmit light. And from physics, you should know that when two medium with one more dense, one lower dense, the reflection cycle may be reflected, so that the less dense medium will have a larger reflected angle. At the interface, if you make the angle so large that it makes the light cannot escape or pass through the less dense medium, or what we have the total reflection. And this angle, so-called the critical angle, okay? And if you have an angle larger than the critical angle, you have the total reflection from the interface between the less dense and more dense medium, okay? And it relies on the light reflection. Now for the optical fiber, we have a glass or plastic core, okay? You can see in the middle, it is made up by glass or plastic, and surrounding by a cladding or less dense glass or plastic, okay? Cladding means it is totally cover the whole inner cable, okay? Or inner material, okay? And the difference in density of two materials must make a beam light move through the coil through the total reflection at the core cladding interface, so that light will not be escaped. You have a reflection of light inside the optical fiber from the sender to the receiver. And so far, we have some propagation modes for the optical fiber. We have single mode and we have multiple mode. And multiple mode can be further divided into step index and gradient index. Now, firstly, the multiple mode means that it supports multiple beams of light that are moving from source to destination in different paths. Okay. And if you are using step index fiber, that means the density of the core remain constant. We do not change the density. okay, from the center to the edge. Therefore, beam of light move at a constant density in a straight line until it reaches to the core cladding interface. And at the interface, it is due to we have a abrupt change, that means a sudden change to a lower density that make the angle of beams become reflected. Okay, and the step index means how sudden of this change. Okay, now you can see on page 33, we have the step mode multipath optical fiber. You can see that many lights can pass through the cable, and they are traveling in a straight line. Okay, and at the core and clipping interface, we have a reflection. Okay, this is the multimode step index. Now, we have another type. Now we have the graded index fiber. Now in this fiber, we find that the reflection index relating to the density of the core, because that the core allowed to have a varying density. It changes its density from the highest at the center of the core and gradually decrease to the edge. Okay, so that the density become vary in the cable in the fiber. As a result, you can see that during the transmission of light, it is not a straight line, but it shows to you a curve in the transmission. Okay, now because it is a multi-mode, therefore it still allow multiple light path through the network. Okay. And finally, we have the single mode fiber. It is using a single step. That means the density should be the same for the core. And the light is highly focused in the center of the core. It allows only a small range of angle during the transmission. And therefore, light is transmitted through horizontally. Okay, you can see the last type, the single mode here, that we only using a very a core with a small radius, and the light will pass through the signal, pass through the fiber straightforwardly, right? Now, actually, compare with three different cable, you can see that the distortion come out from the single mode should be the lowest. It has the lowest distortion. Okay, and you can see that for the guided index, also the distortion it is in the middle, but for the step index, the distortion will become higher. Okay. Therefore, if you can, you are going to choose, you may choosing the single mode. Okay. And here you can see also we describe the fiber size. You can see that it depends on your connection. If you have multi-mode guided index, you may have different core size. It is only in terms of micrometer, a very small cable you can apply to make the transmission. Now, this is another reason why we're using optical fiber, because the size is very small. Okay, even though we have the clipping, okay, it's still in the order of micrometer. Okay. Now, for the fiber construction, now outside the optical fiber, the outer jacket is made up by PVC, the polyvinyl chloride. Okay, it is one of the polymer, or the teleform, PTFE, the chemical lamp. Okay, the full lamp is the polytetrafluoroethanate. Okay, a very long name. Okay, and inside the jacket counter stands, it is another polymer that used to make the bulletproof vest. Okay, 防彈衣啊。Okay, now in order to make the cable to become strong, we using this strong material polymer. Okay, and under the counter, we have another plastic coating that make the cushion of the fiber. Normally, when you have a optical fiber, we don't want to bend it, or otherwise you may break down the cable. Okay, therefore we have some cushion material under the carbon material. Okay, therefore on next page you can see we have the structure. Now in the middle we have a optical fiber, and surrounding it we have the counter material, plastic buffer, and also the outer jacket. Okay, they construct our optical fiber. Okay. And for the connector, you may see that we may have 3 different types of connector. The subscriber connector, if you are subscribing a internet surface using optical fiber, normally we are using this one because it is a connector of cable TV, and it is using a push-pull locking system. On next page, you saw the connector that you just plug the male socket into the female socket, okay, and it can be locked. Until you push a button, it can be unlocked, okay. And we have the ST connector that it looks like the coaxial cable connector, okay. That in the middle we have a boilerlet locking system, and it is more reliable because it can securely connecting to your female sockets. Okay, and you may have the MTRJ socket, okay, and MTRJ stand for the mechanical transfer register jack. Okay, and it is the new type of socket, and actually it supports the 2 cable connecting in the same connector. Okay. Now, so far, do you have any question? And we may now take a 5-minute break. Okay. And we will resume the class at around 4:35.